Most fire detectors only see fire. Ours understands the room. This is FireSmokeDetector, version 0.2. A context-aware vision pipeline that reasons about a scene before it ever fires an alarm. It is in active development and getting smarter every release. On the very first frame, and every time the camera moves or the room significantly changes, we run a heavy scene analysis pass. Depth Anything v2 gives us a full per-pixel depth map, the projection map of the entire field of view. We back-project that into a 3D point cloud, exported straight to a portable PLI file, and render it with Gaussian Splatting, so the model knows the geometry of the space, not just the picture. CLIP labels the location, the occupancy, the visibility, and any flammable materials it can name. A COCO-YOLO pass then catalogues every object in view, and a hazard database scores them. All of this is cached as a scene context, so we only pay this cost when the world actually changes. Between scene updates, we lean on a cheap, no AI proposer. For fire, we vote across HSV, YCrCb, and pure RGB color cues. For smoke, we combine the dark channel prior, saturation drop, Laplacian texture loss, and motion. No neural network, no GPU, just classical computer vision running on every frame. The instant the proposer scores enough hits in a short rolling window, we promote the region to the full pipeline. The trained YOLO fire model wakes up. The hazard engine pulls the cached scene context, and the system explains itself in plain language. What is burning, how close it is, what it could spread to next. Here is the engine actually running. A trained YOLO confirms a fire track, and the hazard engine immediately starts narrating. You can see the depth-derived distance from the camera, the estimated burn area, and a forward spread prediction at 2 and 5 seconds. Risk lines reach out from the fire toward every nearby hazardous object, each labeled with a percentage spread risk based on its danger level and its distance. Every overlay you are seeing is generated live, frame by frame. The fire and smoke detector is a fine-tuned YOLO 11 Nano. It was trained on a unified dataset of 9,000 CCTV, surveillance and real fire images, with hard negatives like artificial fire, sunsets and bright lamps to crush false positives. After 40+ epochs, we hit mean average precision at 50/89%, with precision around 99% and recall around 86%. On a single laptop GPU, the full pipeline runs at well over 30 frames per second, because the proposer is doing the heavy lifting. YOLO alone constantly burns GPU time, even on empty corridors. YOLO plus the hazard engine without the proposer is smarter, but still expensive. Our 3-tier design uses about 1/10 of the compute, while drastically cutting false alarms, because every alert is grounded in real scene understanding. That is the difference between a fire detector and a fire interpreter. FireSmokeDetector is built by Cognitive Industries. The full codebase is heading to GitHub, and a hosted detection API is on the way. Visit cognitiveindustries.org or message admin@cognitiveindustries.org for custom development, partnerships, or any questions about this and our other projects.